Hi, everyone. Good evening. Thank you so much for spending your evening with us at Rakuten Asia. Welcome. My name is Hannah. I'm going to be talking about LangChain tonight, particularly about building your first AI-based applications, just exploring more about the LangChain framework. But before we start, let me introduce myself first. My name is Hannah. I'm currently an associate software engineer at Rakuten Asia. I'm part of the global ads team. I graduated around December 2023, so I've worked for about 1 year and 3 months from Yale-NUS College. It's the one that's closing down this year, FYI. My past experience is before I joined Rakuten, I was a part of the software house company, a German software house company as an intern, which is an AI developer intern. And this is actually where I first learned about LangChain, and I used it during my internship, which is pretty fun. So before we talk about LangChain, can I get a raise of hands if you've ever tried building an AI-based applications? Yes, Thomas. Anyone else? Oh, of course, Daniel. Fun fact: Daniel and I did a hackathon at Rakuten, in which we developed like AI-based applications, which is a UI cards generator. It was so fun. So for those who raised their hands, can you share about your experience building this AI-based application, and particularly what tools did you use? Anyone wants to share? Yes. Okay. Is it? Sorry. Continue. Right. Oh, sounds amazing. Okay. Anyone else wants to share? Okay. Oh, sorry. What's your name?
I'm Sudarshan. Sorry.
That's okay. Suresh?
Yeah, Sudarshan.
Sorry.
GP. That might be GP.
GP. Okay, I'm so sorry. As GP has shared, I guess one way that we can start building our AI-based application is just calling to the API of one of the models. So in this case, I give an example of OpenAI API, which is just a completion API. So certainly you can do this and you can build your AI-based application using this. But of course, if you're just starting out with AI-based application, you want to be able to switch models quite seamlessly. And also, if let's say you want to build a chatbot, for instance, you want to be able to save the previous chats that you've already fed to your model more seamlessly, whereas with using this API directly, a direct API call, you might need to control it yourself. So that's where the LangChain framework comes in handy. So LangChain is essentially an open source framework that simplifies a lot of workflows when you want to build an AI-based applications. So that will hopefully be more clear as we go along this presentation. Can I ask, how many of you have heard about LangChain? Okay, that's quite a lot of people. Amazing. This is gonna be the outline for my presentation. It's gonna be the what and the why, and then I'm gonna talk about the core concepts and demo, including models, prompts, chains, memory, agents, and then I'm gonna talk about the drawbacks and alternatives, and then we can go to Q&A if we have time. So start with the what and the why. So as I've mentioned, LangChain is an open source framework for building applications that are powered by large language models. And it enables us to do integration of LLMs with external data sources, tools, and workflows. In short terms, it's just open source framework to build your AI application. And why do we choose LangChain in the first place? The keyword here is to simplify a lot of complex workflows that are involving like AI or LLMs. And it enables us to do dynamic interactions, chaining, memory, and agent-based decision making. This will hopefully be more clear as we go along. And there are lots of companies that are using LangChain. So Rakuten is actually one of the companies that are using LangChain. The team that I'm working at currently, we're not using LangChain because we're not building AI-based applications. There are also other companies such as Google, BCG, so it is widely used. So yeah, I think now we can deep dive into the core concepts and demo. So the first one is models. And of course, models is really the foundation of LangChain applications, because without it, we can't build anything. And of course, the famous one is GPT, that's from OpenAI, Gemini from Google Cloud, from Anthropic, Llama from Meta, and the most recent one, which is DeepSeek, that created a buzz in the developers world. That is very amazing. So yeah, that's one thing about one thing that's great about LangChain is we can switch amongst models very seamlessly. So let's just do a demo to show how it looks like. Oh, sorry. Let me find where it is. Okay. So of course, you have to first run the OpenAI API key. And then for models, in here, there are two types of model that we can use. There's the completion model and there's chat completion model. The completion model is more generic machine learning task that's more suitable for that. Whereas chat completion model is more chat specifics. In LangChain, the completion model is using some deprecated endpoints and older models. So in this case, we're going to use chat OpenAI, which is the chat completion model instead. So yeah, to initialize it is very easy. Just run chat OpenAI. The model you can specify here. In this case, we're using 3.5 turbo because it's one of the cheapest. And then you can set the temperature to, in my case, I set it to 0.7. If you're not familiar with what the temperature is, it's basically a parameter that influences the LLM's output. Less than 1 meaning it's more deterministic and more repetitive, but more than 1 means it's more creative and random, and by default it's 1, which is a good balance. Yeah, so there are other chat models out there, as we have talked about. Let me just go here. So yeah, with LangChain, there's Chat Google Generative AI. They also have some libraries directly for Microsoft, Anthropic, and etc. So that's one of the main reasons why people use LangChain for this easiness in changing between models. Okay. And the next core concept is prompts. We've heard a lot about prompt engineering. What is it? It's basically learning about how to talk to AI. So prompt is just sending an instruction to the model, and then it will output like the text that's generated by the model, and it can be static or dynamically generated. And let's go to some demo again. Sorry, I don't know why it's not here. So for prompts, there's static prompt like this one. Very easy. Just say, hey, translate the following English text to French. Hello, how are you? And then this is the model that we previously has initialized in here. And you just do invoke with the static prompt. And then when you run this, it will just say, bonjour, comment ça va? Which is what we expected. So this is very simple, same as if you're using your ChatGPT. And there's also dynamic prompt here, in which you can use this prompt template from LangChain. Basically, what this prompt template does is it allows us to do dynamic prompting, to put a placeholder here. So instead of translate the following English text to, say in this case, Indonesian, hello, how are you? We can put a placeholder, and then in the input variables, we can define what that variable is to be replaced. So in this case, the input text I define as good morning, have a great day, and then I format my dynamic prompt template, and then I invoke my LLM, and then it will say, selamat pagi, semoga hari ini menyenangkan. Yeah, so that's on prompting. And there are lots of people who are saying, oh, I've read online that prompt template is essentially similar to F-string. There is not really a need for this, which I guess we can discuss more later. Yeah, so that's for, let me need to go back first. And the next core concept is chains. So chains is essentially a sequence of calls or operations. And the calls can be to LLMs, can be to external tools, or it can be to data pre-processing step. The the graph that I showed here is a simple sequential chain. So basically, you have an input, and then you put it through a chain, and then the output of the first chain will be the next input of the second chain, and then you run it to the second chain, and then you have your output. So I guess to visualize this better, one example for this is, say you want to translate a document that is originally in French, and then you want to translate that to English, and then you want to summarize that document into like a one-liner, for instance. So let's try that. So in the first chain, you have a translate chain, and then the output of that translate chain will become the input of the summarize chain. So the demo for that, is first, of course, you need to import the necessary library for chains. And then for the translation chain, it's the same for the prompt. You can use prompt template, or you can also, this one, prompt template is necessary because you want to have control on the input variables and output variables. And then you can create this translation chain. We're using LangChain, pass in the model, pass in the prompt, and then pass in the output key. So this output key English text is basically the variable name in which we're going to store the result of our first chain, this one. So translate the following text to English. The result of that will be stored here in the output key. So let's run that. And then the second one will be the summarization chain. Similarly, we'll define the summarization prompt template, and then we'll create the summarization chain, passing LLM, passing the prompt, and then the output key for that will be the summary. And this will be the juicy part, which is creating the simple sequential chain from summarizing and then translation. So now you can just use the sequential chain from LangChain. And then in the chains input here, you can give an array of the chain that you want to sequentialize. And then in here, the input variables will be text, because that's the first input that you're giving, which is text. And then the output variables will be two, right? There will be English text and summary. And then this English text will become the input variables of the next one. I think this is a very important part. Okay, so let's run that. Okay. And then we have this input text. They're all in French. I don't understand French. I'm sure some of you might understand French. So now I want to translate this and summarize it. I can just invoke passing the input text into my sequential chain. Let's run that. And so now entering new sequential chain. Okay, so now we have the translated text in here. And then we have the summary, which is AI is the intelligence, so this is what LangChain is actually great for. It's actually really great for chaining. Keep going back to the wrong slides. It's actually really great for chaining, basically to tell the models that, hey, these are the specific steps that I want to take. Yeah. And there are more complex chains aside from the simple sequential chains. There's also, it's called another sequential chain, but I guess there's like some things that are running in parallel, quote unquote. So for instance, in chain tree here, you can pass in the first input to both chain 1 and chain 3, and then the results of chain 2 and chain 3, you can use it as an input for chain 4. There's also router chain. To be very honest, I don't really understand completely, like in much detail, so I'm not going to go deep into that. But just letting you know that there is like a router chain out there. So I guess continuing from our example in translation chain and summary chain, putting these together, let's say we have the third chain, which is asking the LLM like, hey, what language is our user input, like the text that we're inputting. And then maybe in chain 4, we can have a follow-up question chain. Maybe we can ask them, hey, can you maybe generate more text based on the summary and based on the language that the text was originally from. So we can do that. We can do a demo on that. So this is the third chain, which is the language chain. again, like another prompt template, what language is the following review? You see here in the input variables, we use text, which is the same as the first chain here. And then again, run the chain, output key is language. And then for the last chain, which is a follow-up question chain, input variables will be coming from chain, sorry, let me just go back here. From chain 2 and then from chain 3. Chain 2 is summary, chain 3 is language, and therefore input variables will be summary and language. And let's say we want to write a follow-up response to the following summary in the specified language, and then you run this chain. Okay, so now we run the sequential chain again. The same as before, you run an array of chains. You run this input text, and then we'll see the results. So this is the translated text, and then this is the summary, and then this is the language, which is the original language is in French, and then this is the follow-up message from the summary and in the language that we want it to be, which is French. Yes, so that is an example of chain name in LangChain. Okay, are we good so far? Okay, yes. The next one will be memory. So with memory, when we are, let's say, using a chatbot, if the chatbot doesn't remember our previous conversations or they don't have memory, let's say we tell them, hey, my name is Hana, and then we ask them, do you know my name? They wouldn't know because they are states and they don't keep track, they don't have memory, they don't keep track of what we send them before. So that's why memory in this case is important, especially for use cases like chatbot. You want to make sure that you maintain the previous conversations. In this case, if let's say I ask them, do you know my name? Then they will be able to respond based on what we gave them in the beginning. So yeah, basically, it enables the system to retain context across interactions. An example is remembering conversation history. And I think one of the most straightforward memory in LangChain is conversation and buffer memory. What it does is it memorizes all the previous text until we hit the maximum token limit. And with this, the raw input is passed. So let me show an example for this for it to be more clear. So we have this, the libraries being passed. And then in this case, we want to initialize memory, conversation buffer memory. And then we want to create a conversation chain or a chain. In this case, we're using conversation chain because we know that we want to create something more conversational, whereas LM chain is usually more suited for like stateless single step tasks. But you can use both either way. Let me run this conversation chain. And then let's say first interaction, I will say, hey, my name is Hana. Second, I will say I live in Singapore. Third, I will say, what is my name and where do I live? I run this. After I said, hi, my name is Hana, this is what the response is. Hello, Hana. It's nice to meet you. How can I assist you today? And then I say, I live in Singapore. Then the AI will give this very lengthy description about Singapore. And then I will say, what is my name and where do I live? And they're able to retain that information. Your name is Hana and you live in Singapore. And if we run the memory buffer, this is what's happening, what's being stored in the memory. So what's happening was with conversation buffer memory, as we ask more questions, they just append like the previous key texts that are coming from AI and also that's coming from us humans. Yeah, so that's the conversation buffer memory. But of course, there are limitations to this. And the biggest limitation is that once, because we keep sending the previous chat history, it is possible for us to hit the token limit. And for instance, for GPT 3.5 Turbo, the limit is around 4,097 tokens. So that's not very good if, let's say, we want to have a very lengthy, long conversations. So an alternative to that is conversation summary memory. what it does is it memorizes the summary of previous texts instead of appending everything that we have set to the AI or what AI has set to us. So it's just a summary of the previous texts. I think I will not go deep into the demo for this one, but what this does is, let me just show you. With the conversation summary memory, we are passing on the LLM as well, the LLM model to the memory, because we're also summarizing the previous chats using LLM, using the model, whereas previously in conversation buffer memory, you're not passing the LLM down because you're just appending the previous texts. So with this one, I've run this. When I said, hi, my name is Hana, the AI, what it does is it summarizes. So it says, Hana introduces herself to the AI. The AI responds warmly and offers assistance to Hana. Then I say, I live in Singapore, and they also summarize it again. So conversation summary memory is great if you have very lengthy, long conversations. They're not really good when you have very short conversation, because if you see here, if you have very low number of interactions, actually conversation summary memory token per call is higher. And that is because they're actually adding more words if there's not a lot of text in the beginning. So let me show you in this one, right? When I said, hi, my name is Hana, they actually add more words. Hana introduces herself to an AI, la da 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 da, even though I just say, my name is Hana. So because they add more words, they add more tokens. And so when we have a short conversation, actually the tokens per call is higher. But then over time, the longer the conversation is, the tokens per call will be reduced. Yeah, so that's for conversation summary memory. And there's also conversation buffer window memory, which means that we'll only memorize only a number of previous texts. So let me show you this one. So this one, we define K to be 2. That means I will only remember, the AI will only remember the last 2 conversations. So in this case, I said, my name is Hana, I live in Singapore, I love to do canoeing. So that's 3. And then if I ask them, what is my name? They don't remember. I'm sorry. I do not have access to personal information such as your name, because we set the window to only be K equals to 2, which is the past 2 conversations we had. And that doesn't include my name is Hana. Yeah, so that's for the window, the buffer window memory. And the last one is conversation summary buffer memory. This is actually a combination between conversation buffer memory and summary memory. It memorizes summary of previous interactions, but also maintaining the maximum token limit of the recent interaction, which can be great because the bad thing about conversation buffer window memory is you lose a lot of context as the conversations become larger. And let's say the K is not that large, which can be very tricky. But with conversation summary buffer memory, you want to make sure that previous conversations contexts are still maintained with that summary, while also allowing the recent interactions to still be stored. So actually, it looks kind of like this. This is not unexpected that conversation buffer window memory has, like, I guess, the lowest tokens per call. And that is because we're only keeping the last 6 conversations, which is why the tokens is not that much. And yeah, so with conversation buffer window memory, the lower K is the better number of tokens. We're not keeping a lot. With conversation summary buffer memory, as you see here, if the max token limit is also lower, the tokens per call is also better because, again, we're keeping less words in, or tokens in, not words, sorry. Yeah, so that's it on memory. Now we're going to move into agents. We've heard a lot of things about agents recently. A lot of companies now are moving towards wanting to build their own AI agents. So what is agents? Agents is essentially an autonomous systems that use LLMs to decide actions and interact with tools or APIs. So let's say I have this AI agent that can fetch a data to the database for me, that can make a call to external API for me, or do other toolings that I require them to do. And I guess an example for that is a chatbot that retrieves real-time data. So I guess this is why AI agent is really great, because it is able to do a lot of things that we want it to do. And I guess one example that I can show following our examples on translation and summarization is that, let's say we have an AI agent, and then we have 3 tools. First one is translation tool, summarization tool, and calculator tool. I know the calculator is a bit out of nowhere, but adding them there just so that it makes more sense, at least to me, it really helps a lot. So yeah, I think we can show a bit of a demo on this. Let me run this part. Sorry, this. Okay. So of course we want to export like all the necessary libraries, and then we want to define our tools as functions. So the first one is the summarize text function and the translate text function, and we want to run the calculator function, and then we want to put them into the tools. Create structured tools using this function. And we want to, in this case, create 3 tools. We run them. And then we want to define the agent prompt. And then we want to create the agent and also the agent executor. And then this is what happens is in here, we say we have the prompt template, summarize this text. We want to tell AI, hey, please, to the agent, hey, please summarize this text. We run this. Okay. And as you can see here, it invokes the correct tool, which is the summarize tool that we have defined here. Because we have 3 tools, summarize tool, translate tool, and calculator tool. And when we ask them to, hey, summarize this text, the AI agent is able to pick up, oh, we have to use the summarize tool. Similarly, when we ask them to, say, translate this text into Indonesian, when we ask them, again, they're able to pick up here invoking translate, and they're able to translate it to Indonesian. And then when we ask them to, like, hey, please calculate this, they're also able to pick up the correct tool, which is calculator. Yeah, and then the result of the calculation will be correct. So yeah, that's why agent is really great, because you're able to do a lot of things and define a lot of your tool with it. To do the things that you want it to do. And I guess this is like one question that I had as I was learning about LangChain and even preparing for this presentation. I was a little confused between the difference of chain and agents. And I learned that with chain, obviously, as we have talked about this, it's more about the steps. So if you already know what is the procedure that you want your models to look like, chain is great for that, whereas agents is more about what kind of tools you want your AI agent to have, and if they're not really a procedure. So let's say I want my agent to be able to translate, to be able to fetch data, then you can do that. But it's not like chain where the steps is kind of defined in the sequential chain example that we have shown. Yeah. And so actually for agents, LangGraph is better for that. If you want to manage like multi-agents, for instance, LangChain is mostly ideal if you want to do chaining, clear sequence of steps, and modular design. But for agents and multi-agents, I think LangGraph will be better for it. And my colleague Daniel will have his presentation on LangGraph after this. So really excited for that. Yeah, and of course there are some drawbacks and alternatives with LangChain. Personally, I've never really deployed LangChain into production, but I read in some open forum like OpenAI community or other forums out there that the main drawback of LangChain is that it has a very high level of abstraction, which can make it very hard for them to control certain things. So they have lack of control, because with LangChain, as we've seen, it has a lot of magics and voodoos. We don't really know what's happening behind the scene. and sometimes you really want to like change some things, but you can't really do it because it's all within the LangChain library. So yeah, they don't really have like control over it. And they have also mentioned about scalability issues and some difficulties handling large volume of data. And I think this really still comes down to this high level of abstraction. Because again, like if there are some parts that they want to change in their application, it's not very easy for them to do that. I just found this funny meme. It says prompt template is just f strings. Not wrong. I feel like it's kind of true. You don't really need it, to be very honest. But maybe like when the application is very large and there is large use case for it, it can be useful. Yeah, so that's the drawbacks. And there are possible alternatives, like the OpenAI library or SDK, for instance. It's not really like, I guess, a direct comparison, but in the open forum, a lot of people are saying that it's better at the end of the day to just call the OpenAI API directly or even use the library directly. And as you can see here, I feel like this is a very famous picture from DeepSeek API documentations that even in their example, they also use the OpenAI SDK in Python. Same with Meta Llama model. They're also using the OpenAI SDK. And over time, I think OpenAI has become the standard, the library, which is amazing. But yeah, this is one thing that people also mention is the fact that using OpenAI API directly, for instance, or using this library is better in a sense that performance-wise is faster. So that's one thing to consider. And there are other alternatives I found like Haystack, Llama Index. To be very honest, I've never really explored them. But yeah, these are the other toolings that people can use aside from LangChain. Yeah, thank you for listening.
In terms of time, will you still be around later?
Yeah, you can ask later. Yeah.
So maybe after all three talks,